and medical devices, especially devices for micropigmentation. Also, micropigmentation pigment colors complying with the highest quality standards. Thanks to your passion, Thanks to John's passion and affinity to technique and innovation, MTDerm patented and launched a few years ago their revolutionary cartridge system. This cartridge system has become a safety standard within the micropigmentation sector. All MTDerm inventions help micropigmentation professionals all over the world to achieve good results and gain more satisfied customers. In his master lecture, Jorn introduced the new patented feature, SensiDrive. We hope this is a new revolution within the micropigmentation sector. Thank you. A warm applause for you.
Thank you very much. Thank you everyone for coming. I'm just impressed that we have visitors from so many countries, and I didn't know this introduction, and I was really impressed. Also about their language skills, I have to admit. So my presentation will be on the new technology to minimize touch-ups. During the presentation, I will also give an overview on how pigments go into the skin, and also how the pigments survive in the skin. So many of you are very familiar faces, so many of you already have seen some part of this presentation, but it's very important to go through the basic concept, how the pigments go into the skin, because this will be the base to understand why new technology works better. So we basically start with a slow motion picture of a tattooing process. You do see that the needle is stitching the skin. The frequency is very high, so it's actually 150 stitches per second. And you see the needle here is moving in and out, and 150 stitches. This is a slow motion picture. You can also see that the skin is moving away slightly from the needle. This is what we call an umbrella effect, or also Fakir effect. Yeah? See if the skin is flexible, and if the penetration, the speed of the needle is not fast enough, the skin will just move away from the needle without a proper penetration. But you can also see the very high precision here. Yeah? So there's no sideway fluctuation of the needle. That's also very important to cause the least trauma that is necessary to bring the pigments into the skin. So here we have some cross sections of the skin. This is the untreated skin. This is right after the tattooing process. The next one is a couple of hours afterwards, and this is 2 weeks after. So first of all, right after the tattooing process, we see that the epidermis has a lot of inflammation. So the epidermis thickened. We also see that there's a lot of pigments everywhere. Yeah? So the black things are all pigments. And already a couple of hours afterwards, you see that a lot of pigment is removed. And now the question is, why? And there's two ways that the pigment go, and they go this way very quickly. One thing is the pigment gets exfoliated, and on the other side, the pigment is also absorbed to the body, and it is drained through the lymphatic system. Now there's a couple of things also for devices, also for pigments, which are important and which are to consider here. Because if the pigments are exfoliated, it means they are pushed out by wound liquids. If there's an exposure of lymphatic fluids and of blood, and it's too much of it, it will just push out, wash out the pigments from the dermis, where you want the pigments. In other words, so you should not go too deep, because then you will cause too much flow of wound liquids. On the other hand, if you go too shallow, not enough pigments will stay, because they will also just grow out together with the epidermis. So it's very critical to have the right depths. Another critical fact is you have to make sure that you do not cause too much trauma to the skin. So if you have devices which vibrate too much, they will tear the tissue sideways instead of entering and exiting the skin with a very perfect, precise stitch. So here you see the final result, and this is the healed skin, basically, almost completely healed, and you see that the pigment is placed in the dermal layer of the skin. This is where the pigments are survived, where they are surviving. So, why are they surviving? During the tattooing process, there is an inflammation. That means, at the same time, activity of macrophage cells. That means macrophage cells move into the inflammation site, and they eat the pigments. Sometimes they eat one pigment, sometimes they eat several pigments, sometimes they eat agglomerates of pigments. These macrophages can take several times the size of their original size. So when they eat too many pigments, they're too big. That means they cannot drain through the lymphatic system anymore. So they stay in place, they go through an apoptose, which is a natural cell death, and this is where they stay engulfed on site. So there's a more schematic presentation on where the pigment should go. It's the upper third of the dermal layer. So this is now the basic theory, and now the question is, how should devices be composed to perfectly implant pigments into the dermal layer of the skin? These are all aspects I will go through, and then I will go through the new technology. First of all, it's precision. Why precision? Because we don't want to cause too much trauma. We have a digital control frequency. That's important so that the line is very even, that we don't have lines where there's a lot of pigment and then we have blank spots and then we have a lot of pigment, so we want even lines. The needle speed. This is to prevent the umbrella or fakir effect. We want to penetrate the skin fast so that the skin doesn't have the time to move away from the skin, from the needle. We have the penetration angle. I will go into this in detail. We have the needle surface, needle shape, and safety. I will go further into these things. Here you see a big difference. This is one of our precise devices, and this is like a low-cost device. And what you see, the difference is once in the size of the stitches, but it's also in the distinction. So you see there's no sideways vibration. It's going very precisely in and out. So you cause a lot less trauma here. Also here you see that this has been torn. It's on paper actually. This is paper. So the paper has been torn, and also the needle didn't fully retract. This is something that you will experience as hooking. So if you go over the skin with your pen and you feel it's hooking, this is what's happening. The needle is not fully retracting. You cause a lot of damage, and actually it's more painful to the client also. So therefore precision is very important. So here this is another high-speed camera, and you can see here how much time has passed right now. So in reality, only 1 second. No, sorry, 0. I can read from here. Yeah. So in reality, only 0.3 seconds have passed now. Yeah. So you see, it's very, very fast. This on gelatine. Very interesting to see when you look very closely. It may not be big enough for everyone to see, but the color is not inserted with the first stitch. The color is actually inserted with the second stitch. So you always have one stitch where the hole is prepared, and then with another stitch, the color is stuffed into the hole. Yeah? So that means also the precision is important, because if you have a machine that goes right and left, you don't place as much pigment in the skin. The next one is the control of the frequency. So, like with a digital device, the frequency remains the same. When the frequency remains the same, also the distance between each steps, each stitches, remain the same. As long as you have a continuous drawing motion, of course, with your hand. Yeah? So, this is important because otherwise, if you go to harder skin areas or thicker skin areas, what happens is the frequency of the machine drops. When the frequency things. And needle speed means how fast does the needle move into the skin. What we see here is that if the needle goes slow, too slow, it will take the skin with it, yeah, in both directions, down and up, yeah. So that's not a good effect, because this will also lead to catching of the needle in the skin. That will lead to more pain, that will lead to more exposure of blood and wound liquids, and the result will just not be okay. So therefore the perfect thing, which no one can achieve, but the perfect thing would be a very fast needle, which does not, you know, push away the skin or, you know, take the skin with it when it's drawn back. The working angle. So for example, if you would like to achieve a depth of 0.8 millimeters, there's different ways to achieve it. If you go in a 90-degree angle, you will actually, the needle length measured from the tip of the tube will be equal the penetration depth. If you change the angle, and also, for example, tattoo artists, they all work in an angle, and also with most techniques, I think you will work with an angle, but also positive, according to, you know, your personal preference. If you go at an angle, then you will need to turn out the needle 1.15 millimeter instead of 0.8 millimeter to achieve the same depth. That's also to take into consideration. If you tilt the pen, you need to turn out the needle further. You need to penetrate further. This gives the following advantage because the surface of the needle is larger when you go in with an angle. Because here, you're in the skin for 1.15 millimeter. That also means that there's more needle surface in the skin. More needle surface in the skin means there's more pigment carried into the skin. So that was an invention by Dr. Linda Dixon. She will also do a presentation tomorrow. Unfortunately, she couldn't come because of the storm Sandy in the US. So, but she will still be with us, not only in our minds, but also by telephone, because she will give her presentations through the telephone, and she will be on the phone, and we will display her slides. This will be tomorrow at 10:15, and her invention was to have. Okay, here we go back. Okay, so this is not a slope needle, but this is a regular, let's say, what is it, 5 needle or something. So if you tilt the needle, or the pen, what we recommend, but if you then put it on the skin, what you see, it's not automatically easy, what you see is that the needles are all in the skin at a different depth. Yeah, so that will give you an uneven result. Yeah, you want the needles at the same depth. And so the invention is this. You use needles which are arranged in a slope. So that means you can tilt the pen to the side, and at the same time all the needles will penetrate at exactly the same depth. So the needles are already, I call it pre-tilted, and also the needle tube is tilted. Yeah? So that will ensure a very even result. This needle is good for, especially for shading, because you can perfectly cover larger areas for lip shading, but also for areolas, so for medical tattooing. So this is also shortly after the tattooing process, the cross sections through the skin. What you see here is that here the pigments are mainly in the dermis, but what you also notice, and this is the single stitches. So it shows us that a lot of pigments actually wiped off at the surface of the skin. Yeah? So we see that a lot of pigment is lost on the surface. So we have to work on needle design to reduce this effect. So for example, it's very important to use needles with a rough surface because they will carry more pigment. If you have a very smooth needle or a coated needle, for example, what will happen is like with the windshield wiper. Yeah? So all the color is wiped off at the surface of the skin. So therefore, we believe that the rough surface will bring in more pigment compared to smooth needle. Okay, so we have talked about precision to reduce the trauma, to reduce the exposure of wound. We've talked about the digital control to have a more even line, a more continuous line, a more reproducible line. We talked about the needle speed to reduce the fakir effect or the umbrella effect. We talked about the penetration angle. We talked about the needle surface. Another one is the needle shape. So how should the needle be shaped to have perfect penetration? And there also it is the same topic. It is, we don't want to cause too much trauma, like a more blunt needle will cause more trauma. At the same time, we want to increase the volume of the needle. So what we found out is that the bullet point needle, for example, is the needle which will bring the best compromise between trauma and needle volume. And safety, of course. Safety is the most important aspect. And you have to make absolutely sure that you work with a device where no color can run back into your handpiece. And you can check that very easily. So you take a little cotton tip, yeah, and you insert it into your handpiece, and then you see, and you can tell if there's color on it. That means color runs back. When color runs back, wound liquids can also run back. A very important safety aspect. Okay, so there's a new concept. We call it a SensiDrive. And here we measure the resistance of the skin, like how thick, how dense is the skin. And the handpiece recognizes that, the machine recognizes that, and then, according to the presetting and the application that you need, we adjust the power. So we can not only adjust the frequency, we can also adjust the power. Yeah, well, the device also is certified. We have several patents. We are actually more like our company, we're a research-based company, and we have several fields where we apply the outcomes of our research. Okay, this is the device which we use. One interesting difference also is from the pen. So if you look at this type of pen, for example, which we also use, but here you see the disadvantages. You have to attach like the barrier film to the pen, and then you have to have another coating, and then you have the cartridge. So that means there's a lot of steps. Or you can also use the barrier film and attach the barrier film to the front. But then you have to grab the pen through the barrier film, which gives a little bit, not of a tight feeling. So therefore here, the advantage is we have one cartridge, which is this size, And then you attach the barrier film here to the back end. And the area where you would grip the pen is right here. So that means you have a tight grip on your handpiece and it's not slippery because of the barrier. Okay, let's get to the sensor drive function. So what we see here, this is the screen of the device, and you can set the speed or frequency here, and here this is the sensor drive function. So the sensor drive function you can set it by yourself, the power, but you can also go with recommendation. This is how it looks like. So, for example, it shows you there's a 3-point needle attached. Machine recognizes which needle is attached. And then it gives you an overview over what you could do with a 3-point needle. So here, for example, the user chose to find hair stalks. Yeah? And then there will be a presetting. And the presetting will determine also the power. So it's depending on whatever you want to do, and it's depending on which cartridge is attached. And out of these parameters, plus the resistance of the skin, the optimal power setting is generated. I will show it to you here. So this is, for example, the soft setting. What happens with the soft setting? In the soft setting, when the density of the skin is increased and the resistance of the skin is increased, the needle speed will actually slow down, the power will slow down, the frequency drops. That means that the pigment is rather placed, somewhere in the epidermis and maybe not deep enough. Why would you want to use this feature? For example, for shading, because you get more feeling for the skin. Yeah? So you have a little bit more of a feeling over the resistance, because it's a very soft reaction to your pressure. Yeah? So then we have the neutral setting. In a neutral setting, sensor drive is set to 0. What happens is you have a very stable frequency. This equals the digital control of the frequency. The frequency remains the same, no matter what happens. It always remains the same. No matter if uphill or downhill with the car, always remains the same. The disadvantage here is that in this area, for example, where the skin is more dense, where it's more thick, the pigments will be placed in the epidermis, and it may not be deep enough. So therefore there's a power setting. And the power setting is doing this. Now it's getting to harder skin areas, and the frequency and the power is increased. So that means that all the pigments are inserted into the right depths. The power goes up because the skin is higher. Skin resistance is higher. Some high-speed camera. This is a silicone. This is a silicone pad, and now the pens are moved towards the silicone pad. So you will see that the needles are stitching into the silicone pad. This here on the left side is basically the reference. So this is like a neutral setting. This is the digital control. 0, sensor drive 0. Yeah? And you notice with the power setting, compare the frequency. You have a much higher frequency here compared to here. See the soft setting. Once the needle goes into the skin, you see the frequency slows down. Yeah? I will repeat it because I think it's more easier to see after I have actually described it. Okay, so all the frequencies are the same now. Okay, all 4 pictures show the same frequency, and now you see here the needle is entering the skin, and you see the frequency is going faster. Frequency is going up, power is going up. Now the soft setting is entering the skin, and you will see the needle frequency will slow down. Penetration only from here until there. Yeah? So that means the power setting will also give you more equal depth. But if you go too deep, you can go too deep with any machine. But if you go too deep, you know, you have to be careful with the plus setting.